Assalamualaikum warahmatullahi wabarakatuh to everyone that watched my video, especially to my first panel Dr. Huda bin Majid and my second panel Encik Muhammad Hakimi bin Zohari. My name is Amar Aizad, and in this video I am going to present my final year project 1, and the title is Agricultural Pesticide Spraying Robot System. My supervisor name is Miss Sumaiya Binti Mashori. Regarding the introduction of the project, I would like to describe the background of the project. Chili. Chili is a fruit-type vegetable and it is popular in Malaysia. Chili was originated from Mexico and South America but adopted to Malaysian tropical climate many decades ago. In 2009, about 1,500 hectares of chili was grown in Malaysia annually in major producing states such as Johor, Perak and Kelantan. Chili was suitable in temperature from 20 to 30 degrees Celsius with rainfall between 1,500 mm to 2,000 mm monthly, and it can adapt to pH between 5.5 to 6.8 on mineral soil, peat or breeze soil with a proper irrigation system. Red chili or green chili are the product depend on harvesting period and different market needs. Study shows that Malaysian took 33,000 tonnes per year of fresh chili annually, whereby the local production around 23,000 tonnes per year. Chili rich in nutrient content, and it reported that every 100 gram of chili contain carotene beta, phosphorus, niacin, vitamin B1, B2, C and so on. According to Nation's Encyclopedia, agriculture continues to be a significant sector in Malaysia, contributing 12% to the national gross domestic product GDP and employing 16% of the population. As a result, chili demand has soared in market value. The use of technology is essential for farmers to increase their production and profits. As a result, the adoption and use of new technology are crucial to the agricultural sector's development. To satisfy this country's population's food demand, farmers must use a large amount of pesticides to increase food production. However, spraying pesticide is a hazardous procedure for farmers, and several precautions should be considered, such as wearing appropriate clothing, gloves and masks. Spraying pesticide manually result in an ineffective and uneven coating of pesticides, requiring more significant quantities of pesticides. Thus, robots are a very eminent technical solution for achieving the best solutions in such situations to increase productivity and reliability. Crop attack is an important issue in limiting agricultural production growth. Around 26 to 40% of the world's crop production is expected to be lost to weeds, pests and diseases. One standard method of resolving this issue is to implement pest control. One of the traditional methods of applying pesticide by spraying chemical onto crops, and it is a quick and effective way to eliminate pests. However, the time required for the manual spray is long and it is a tiresome exercise. Moreover, cost increases as a farmer require additional pesticide volumes when there are already enough. While pesticides are useful for controlling various pests, spraying pesticide is a hazardous procedure for farmers. Direct exposure to pesticides will be very harmful to farmers and can cause a number of health effects. They are linked to a range of serious illnesses and diseases, from respiratory problems to cancer. There are several project objectives that will be achieved by the end of the project. The first project objective is to develop a highly efficient agricultural pesticide spraying robot attached with ultrasonic sensor that to be used in a chili plantation. The second objective is to program ultrasonic sensor to act as input and the spraying system to act as an output in a chili plantation. The third objective is to develop the entire robot, starting with the design of the four-wheel car based mechanism, and it is controlled through Raspberry Pi. The final objective is to evaluate its effectiveness in pesticide usage by the system and the result of the infected leaves before and after spraying. For the project scope, the APSR System main processing unit is a Raspberry Pi. The Python software is used to program combinations of inputs and outputs. The device is capable of transporting less than 2 liters of liquid pesticide at a time. 2 ultrasonic sensors will be attached to the APSR system to detect the targeted chili plant. The project's limitations include the system's inability to be used in plantations that are not organized in a row or a straight line. Additionally, the rover is capable of carrying a small quantity of liquid pesticides at a time. Only loads weighing less than 2 kg are permitted. Additionally, the rover that will be used is necessary to have a smooth or ground floor. Next is literature review. Modern farms and agricultural operations work far differently than those a few decades ago, mainly because of advancement in technology including sensors, actuators, devices, machines, and information technology. Today's agriculture routinely uses sophisticated technologies such as robots technology. These advanced robotic systems allow businesses to be more profitable, efficient, safer, and more environmentally friendly. To proceed with the project's development based on the research conducted, it is necessary to list out the unique and essential criteria from the related research. For the controller, each case study makes use of a different types of controller for a particular task. The projects are constructed using well-known development platforms such as Arduino, Raspberry Pi, and PIC microcontroller. For the sensors are essential to the system functionality. Sensors are used to detect and measure changes in the environment. Each one performs a different purpose within the system. The sensors used in the device described in the studies are ultrasonic sensor, LDR sensor, float sensor, and IR sensor. For the actuators are devices that operate in response to a signal received from the sensor, and actuators are the components of a machine that move and control a mechanism or system. The outputs and actuators used in the studies are DC motor, stepper motor, servo motor, and water pump motor. Apart from the system's input and output, several additional features are used to enhance and optimize the system automation and sustainability. The additional features are used in the studies are solar panel, LCD, LED, buzzer, GSM module, camera module, GPS module, Bluetooth module, and Wi-Fi module. After reviewing the case studies, the idea to build APSR system has emerged. For the hardware from the case study, Raspberry Pi as the main controller is the best choice for the system due to it can execute multiple programs in the background while activated, and it is also capable of multitasking. From the case study, one of the case studies is from the previous semester project. One of the senior BND student projects is pesticide spraying robot. APSR system is the improvement of the previous project, whereby one of the improvement is changing the main controller, which is from 2-unit Arduino Uno for controlling the system change into 1-unit Raspberry Pi. It improved the complexity of the hardware circuit. Raspberry Pi is ideal for building a difficult project such as an advanced robot. Python software is used for the operating system of this project. Another improvement is adding a solenoid valve into the APSR system. For example, in the previous BNE student project, when the robot detects a plant on one side, for example on the left side of the robot will spray on both sides because the robot only has one solenoid valve. For the APSR system, with the addition of another solenoid valve, the robot will spray at the site where the detection of the plant coming from. If the robot detects on the left side, it will spray the pesticide only on the left side of the robot. For the sensor, APSR system will use waterproof ultrasonic sensor because it has a better performance and it is compatible with harsher environments. And the important thing is it is waterproof component. In terms of the spraying system, the diaphragm pump is a key element of every sprayer since it ensures the flow rates and pressure required for each specific treatment. APSR system will use a double suction electric self-priming diaphragm water pump. Double suction mode increases efficiency for spraying system. The APSR system consists of 4 elements, which is control module, driver module, spray module, and tank level. For the control module, the main component of the circuit is Raspberry Pi controller, and it is also known as the heart of the robot. A driver circuit is connected to Raspberry Pi, which is used for the movement of the robot. A spraying circuit also is connected to Raspberry Pi, which is used to spray a plant. For the driver module, it consists of 2 components, which is L298N and worm gear motor. The driver module is used to control the directions of robot and it is connected to the APSR system. For the spray module, it consists of ultrasonic sensor, diaphragm pump, and nozzle. The spraying mechanism is used to spraying the pesticides in the farm and it is connected to the APSR system. For the tank level, it consists of a float sensor and LED light. When the tank is empty, the float sensor will turn on and the LED light will act as an indicator light to notify the user that the tank is empty and need to be refilled. The methodology is an important process to ensure the system develops and runs well according to the earlier objective. Besides, a lot of mistakes can also be prevented through this process. For the project planning, the project is divided into 4 stages, which are: first stage, project proposal preparation and planning; second stage, hardware and software development; third stage, hardware and software interfacing; and the final stage, report submission and project presentation. In final year project 1, the project is done until stage 2. However, in final year project 2, the project planning is continued from stage 2 until complete. In stage 1 of project planning, a project proposal is prepared. Before preparing the project proposal, many studies are done related to the scope of the study. Brainstorming is the very first step for starting the project. An idea comes from the supervisor and previous studies giving multiple options to decide and proceed with the project and choose the best and relevant idea. The idea that has been chosen is the agricultural pesticide spraying robot system, which is the best and relevant idea due to the benefits gained from the project's development. In stage 2 of project planning, there are two separate parts in this stage, which is hardware development and software development. To successfully develop the APSR system, project flowchart, block diagram, and system design are required. For the flowchart of the APSR system are divided into two parts. For the first part, when the system is connected to a power supply and it is turned on, all input and output functions is initialized for the first time. Next, the system will proceed to move in a straight line. Afterwards, two ultrasonic sensors will emit ultrasonic wave and preparing to detect plants along the way. If one of the sensors senses the plants, the spraying process would proceed to spray at the site of which the sensor is triggered. For the second part, when the sensor senses a plant, the robot will stop moving. Subsequently, the diaphragm pump is started to run and a solenoid valve is actuated, allowing the liquid pesticide to flow from the tank to the spray nozzle. Next, for the block diagram, it shows a simplified block diagram of the project. One unit of Raspberry Pi is used as the main controller unit. Raspberry Pi was powered by an external DC battery. The system consists of two input sensors, namely left and right ultrasonic sensor, connected to Raspberry Pi. In conjunction, there is two output which are 5-volt relays that control a diaphragm pump and a solenoid valve respectively. Raspberry Pi also will connect to the motor driver, which run a command to control all 4 DC motor. Then for the system design, the basic spray system is designed and a picture of the design is drawn. Firstly, this is the side view design of the APSR system. Next, this is the top view design of the APSR system. And finally, this is the front view design of the APSR system. In conclusion, robots are a very eminent technical solution for achieving the best solutions in such situations, such as in the agriculture field, which will increase productivity and reliability. Moreover, it becomes a financially viable technological solution. That's all from me. Thank you.